we start the next topic of differentiation, which is logarithmic differentiation. You know about logarithm. In 11th standard, we study the special topic which is logarithm. What is logarithm? If the difficult calculations are given and it is also difficult to solve, then we can use log there. After using log, calculation will be simplified easily. Here, logarithmic differentiation means complicated function given by its formulas, which is that involve product. It means that two functions are given in the multiple of multiple forms and quotients, and power can often be simplified more quickly by taking a natural logarithm on both sides. They enable to use the law of logarithm to simplify the function and differentiate easily. In these terms, the logarithm, especially in the form of y is equals to f of x raised to the power g of x. In the differentiation on the derivative and the derivative, there is no formula available in form of what is the derivative of f of x whole raised to the power g of x. We don't know about derivative of x raised to the power x. We don't know about derivative of sin x raised to the power x or x raised to the power sin x. If we have to solve this complicated function, then we can use logarithm or log here. After using log, we can differentiate given function and find derivative very well. The given function, if the given function is y is equals to f of x raised to the power g of x, we have to find dy by dx, or we have to differentiate given function. But there is no formulas available on the functions of f of x raised to the power g of x. Then we can apply log here. If we apply log both sides, it means that first step to apply the logarithm, taking log both sides. If we take log both sides, then we can write it left side log of y, right side log of f of x whole raised to the power g of x. You know about the rules of logarithm. The first rules of logarithm, which is log of m raised to the power n is equals to n log m. Hence we can write it log of y is equals to g of x into log of f of x, log of y. The given function is in the form of x. If we differentiate given function with respect to x, then derivative of y is 1 by y dy upon dx. It is compulsory. The derivative of log y with respect to x is 1 by y dy by dx, because y is differentiable function and differentiate with respect to x. Y is not constant function. If the y is constant function, then their derivative is 0. But y is differentiable function because y is equals to whole with respect to x function. If we differentiate given function with respect to x, then first we consider that function log of y, and we have to differentiate with respect to x. Then first we consider that function y x, and after that we take a derivative of log of x is 1 by x. Derivative of log of f of x is 1 upon f of x, and here f of x is y. After that we can take again a derivative of f of x means y. Hence we can write derivative of log y is 1 by y dy upon dx by using the rules of derivative of log of f of x. Here we consider f of x is y. Then we can take a derivative of f of x into again derivative of f of x. After differentiating, we can write the derivative of log y is 1 by y dy by dx. Here, g of x and log of f of x be are two functions and both are in multiple forms. If we take a derivative of g of x and log of f of x, then we can use here the rules of log of u into v. By using the rules of log of u into v, we can solve and take a derivative of g of x into log of f of x. If we differentiate the given function, we can write it 1 upon y dy upon dx is equals to here g of x into derivative of log of f of x plus log of f of x into derivative of g of x. Now we know that the derivative of log of f of x is 1 upon f of x. After that we can take again a derivative of f of x plus log of f of x as it is, and the derivative of f of x is g dash of x. Hence we can write derivative of f of x is f dash of x, g of x into f dash of x upon f of x plus g dash of x into log of f of x, which is the required derivative of 1 by y dy by dx. We have to find only dy by dx, hence we can transfer this y on the right side. Therefore, derivative, which is the required function y, we can write it y into log of f of x, g of f of x into f dash of x upon f of x plus g dash of x into log of f of x, which is the required derivative of given function with respect to x. By this process, we can find the derivative of this function. This process to finding the derivative is called as the logarithmic differentiation. For example, generally we have to find a derivative of, if their question is find dy by dx and the given function y is equals to x raised to the power x. If we differentiate given function with respect to x and find the derivative of y, which is dy by dx, there is no rules of in derivative, which is f of x raised to the power g of x or x raised to the power x. If we have to differentiate given function, then before the differentiation we take first log both sides. Hence we can find derivative by using log only this type of function, which is x raised to the power x. First we take log both sides. If we take log both sides, then we can write this function as log y is equals to, it can be write as log of x raised to the power x. If we differentiate the given function, we can write first x log of x, which is log of y. After differentiating with respect to x, we can write derivative of log y. We know derivative of log y is the derivative of log of f of x is 1 upon f of x into again a derivative of f of x. Similarly, we can apply here y is not constant function because y is a differentiable function. If we have to find a derivative of this function, then we can consider the value of x. Means we can find a derivative of x log of y. We can find again the derivative of x into log x. Now we know that the derivative of log y with respect to x and y is a differentiable function, then we consider y is f of x. By applying this rule, we can write the derivative of log y is 1 upon y, and we take again derivative of f of x, which is y, dy by dx is equals to, here we apply the rules which is derivative of m into n. We know that here x into derivative of log x plus log x into derivative of x. X into derivative of log x is 1 by x plus log x into derivative of x is 1. X here x is cancelled. 1 plus log of x into 1, which is value of 1 by y dx. But we have to find a dy by dx. Then we transfer this y on the right side and we can write it dy upon dx is equals to y into 1 plus log x. And the value of y is x raised to the power x, hence complete derivative of which is function is x raised to the power x is the value of y is x raised to the power x in bracket 1 plus log x, which is a required derivative or which is a derivative of y, means the value of dy by dx. Similarly, we can find the derivative of more functions. Similarly, given function is also complicated function. If we can try to take a direct differentiate, then we can find derivative of a to the power x, because the derivative of a to the power x is a to the power x into log a. We can find again derivative of e to the power x, because the derivative of e to the power x is equals to e to the power x. But there is no derivative of sin in the format of sin x raised to the power x. If we have to find the derivative of this function, then we can solve only by using logarithmic differentiation, because sin x raised to the power x is a function and which is a complicated function. If this type of function we want to differentiate, then we first take, let u is equals to a to the power x, v is equals to sin x raised to the power x, and w is equals to e to the power x. Or then we can write y is equals to u plus v plus w. Now if we differentiate a given function with respect to x, then we can write derivative of y is dy by dx is equals to du by dx plus dv by dx plus dw by dx, equation number 1. After that we can substitute whole values. First we take v is equals to sin of x raised to the power x. Again it is a complicated function in the power form. If we have to find the derivative of this function, then we first take a log both side. Taking log both side, v become log v, and it is log of sin of x whole raised to the power x. Also it can be written by using log of m raised to the power n is x log of sin x, which is a value of log v. Now if we differentiate the given function with respect to x, then we can write a derivative of log v, which is 1 by v dv upon dx, because v is a differentiable function. After applying the derivative of u into v, we can write it x into derivative of log of sin x plus log of sin x into derivative of x. After that, x into derivative of log of sin x is 1 upon sin x into again a derivative of sin x plus log of sin x as it is, and we can write the derivative of x is 1. Here sin x, derivative of sin x is cos x. Cos x upon sin x plus log of sin x. Now cos x upon sin x is a cot x. X cot x plus log of sin x, which is 1 upon v dv upon dx. But we have to find the value of dv upon dx, hence we can write dv upon dx is equals to v into x cot x plus log of sin x. We know that The value of x, v is sin x raised to the power x, hence we can write sin x raised to the power x into x cot x plus log of sin x. If we put this value dv upon dx, then we can write equation 1 become, and equation 1 is dy upon dx is equals to du upon dx, and the value of u is a to the power x plus dv upon dx, which is we can write whole derivative of the given function is sin of x raised to the power x or into x cot x plus log of sin x. After that, dw by dx is derivative of e to the power x. We know that the derivative of a to the power x is a to the power x into log a plus sin of x raised to the power x into x cot x plus log of sin x into plus derivative of e to the power x is derivative e to the power x, which is a required derivative of y dy upon dx. These types of examples or question we learned already in class 11. After that, more complicated function we learn next topic in the question number 1. After the introduction, we start question number first, which is in solve example, differentiate the following with respect to x. And the given function y is equals to x square plus 3 whole bracket square cube root of x cube plus 5 whole square upon under root of 2x square plus whole bracket cube. You know about the given function, so much complicated. In numerator there are two functions and it is in a multiple form, and this whole numerator there is under root of 2x square plus 1 whole raised to the power 3 is in quotient form. If we apply the rules of derivative, which is u into v, u upon v, then we can't solve this example. But if we apply the log, then we can solve this function and we can differentiate and find the value of dy by dx. You know about the rules of logarithm. The rules of logarithm, if there are two functions, and we know that first rule log of m raised to the power n is n log of m. You know about log of m into n is log m plus log n, and log of m upon n is equals to log m minus log n. If we apply here quotient form, first we consider numerator is m and denominator is n, then we can apply log n. First we can write this function, first we can write it x square plus 3 whole bracket square. This cube root we can write also x cube plus 5 whole raised to the power 2 upon 3 upon this square root right also 2x square plus 1 whole raised to the power 3 by 2. Now we take log on both sides. If we take a log, then y become log of y. This function we can write it log of x square plus 3 whole bracket square x cube plus 5 whole raised to the power 2 by 3 and 2x square plus 1 whole raised to the power 3 by 2. If we consider the first function whole numerator is m and denominator is n, then we can apply here log of m upon n is log m minus log n. Hence we can write it log of x square plus 3 whole bracket square into x square plus 5 whole raised to the power 2 by 3 minus log of 2x square plus 1 whole raised to the power 3 by 2. Now again here we can apply log of m into n, and log of m into n is log of x square plus 3 whole bracket square plus log of x square plus 5 whole raised to the power 2 by 3 minus log of 2x square plus 1 whole raised to the power 3 by 2. Now we can apply here the rules of n log of m raised to the power n, which is n log of m. These two we can write 2 log of x square plus 3 plus 2 by 3 into log of x square plus 5 minus 3 by 2 into log of 2x square plus 1, which is the required value of log y. Now, if we differentiate the given function with respect to x, then we can write it differentiate the given function, whole given function log of y is equals to 2 log of x square plus 3 plus 2 by 3 log of x square plus 5 minus 3 by 2 log of 2x square plus 1. If we differentiate given function with respect to x, then we can write the derivative of log y, which is 1 by y dy upon dx. 2 is constant function, and we can write a derivative of log of x square plus 3 is 1 upon x square plus 3, and we take again a derivative of x square plus 3 plus 2 by 3 into derivative of log of 1 upon x square plus 5 is 1 upon x square plus 5, and we can take again a derivative of x square plus 5. After that, minus 3 by 2 is a constant function. We can write the derivative of log of 2x square plus 1 is 1 upon 2x square plus 1, and we can take again derivative of this considered function, which is derivative of 2x square plus 1. Hence we can write it 2 into derivative of x square is 2x plus derivative of 3 0 upon x square plus 3 plus 2 by 3 into derivative of x square is again 2x plus derivative of 5 0 upon x square plus 5 minus 3 by 2 into derivative of 2x square is 4x plus 0 upon denominator 2x square plus 1 as it is. Hence we can write it 2 into 2 4x upon x square plus 3 plus 2 into 2 4x upon 3 into x square plus 5 minus 2's 1 and 4 2 6x upon 2x square plus 1, which is a value of 1 by y dy by dx. We have to find the derivative of y dy by dx. It means that we have to find only value of dy by dx. Then we shift this y on right side. Then we get required value, which is dy by dx. Y is divisible. If we shift it right side, then we can write y into 4x upon x square plus 3 plus 4x upon 3 into x square plus 5 minus 6x upon 2x square plus 1. The value of y is x square plus 3 over bracket square cube root of x cube plus 5 whole bracket cube into 2x square, x square plus 5 whole bracket square into upon under root of 2x square plus 1 whole bracket cube. Also we can write, here x square not x cube. Similarly we can write here x cube, again derivative of x cube plus 5. The derivative of x cube is 3x square. Here 3 cancel, we can write 2x square. Hence it is 2x square 3. Therefore the derivative of y dy upon dx is 4x upon x square plus 3 plus 2x square upon x cube plus 5 minus 6x upon 2x square plus 1, which is the required derivative of y, dy upon dx. Next example number 2. Y is equals to e to the power x square tan of x raised to the power x by 2 upon 1 plus x whole raised to the power 3 by 2 into cos cube x. The given function is in a complicated form. If we apply log both sides here, then we can write it taking log both sides. Y become log y. Here given function log of e to the power x square into tan of x whole raised to the power x by 2 upon 1 plus x square whole raised to the power 3 by 2 into cos cube x. If we apply here log of m upon n, which is log m minus log n, by applying this we can write it log of e to the power x square into tan of x whole raised to the power x by 2 minus, again log n is log of 1 plus x square whole raised to the power 3 by 2 into cos cube x. Now again the given both logs are in the form of log of m into n. We know that log of m into n is log m plus log n. After that we can write it log of e to the power x square plus log of tan of x whole raised to the power x by 2 minus, again we can write log of 1 plus x square whole raised to the power 3 by 2 plus log of cos of x whole bracket cube. If we apply again log of m raised to the power n, then we can write n log of m. Log e raised to the power x by 2, we can write it x by 2 into log e plus x by 2 into log of tan x minus 3 by 2 into log of 1 plus x square plus minus again minus 3 into log of cos x. Now if we differentiate with respect to x, then we can write derivative of log y, which is 1 by y dy by dx. Here log is constant function and the value of log e is 1. Hence we can write a derivative only derivative of x by 2 plus here x by 2 and log of tan x, which is two function in multiple form. Then we can write this derivative by using u into v, x by 2 into derivative of log of tan x plus log of tan x into derivative of x by 2 minus 3 by 2, which is constant function. We can take derivative 1 plus x square minus 3 is again constant function. We can take a derivative only log of cos x. After that, if we shift this y on the right side, then we can write dy upon dx is equals to y into derivative of x square is 2x plus x by 2 as it is. Derivative of log of tan x is 1 upon tan x, and again derivative of tan x is sec square x plus log of tan x as it is, and the derivative of x by 2 is 1 by 2 minus 3 by 2 as it is. Derivative of log of 1 plus x square is 1 upon 1 plus x square, and again derivative upon is 0 and x square is 2x minus 3 is constant. Derivative of log of cos x is 1 upon cos x into again the derivative of cos x is minus sin x. We know the value of y 2x plus x by 2 tan x means cot x. This 1 upon tan x means cot x. Cot x into sec square x is cos x upon sin x into sec square x means 1 upon cos square x. Here cos x cos cancel. We can write 1 upon sin x into cos x. Hence we can write also it 1 upon sin x into cos x plus 1 by 2 log of tan x minus here 2 to cancel 3x upon 1 plus x square minus minus plus 3 into sin x upon cos x is tan x. Also we know that put this value of y e to the power x square into tan of x raised to the power x by 2 1 plus x square, the value of y as it is into 2x plus x into 1 is x. We know that 2 sin theta into cos theta is sin 2 theta and 1 upon sin theta means cosec theta. Hence we can write it 2 sin x into cos x 1 upon sin 2x and 1 upon sin 2x is cosec 2x plus 1 by 2 log of tan x minus 3x upon 1 plus x square plus 3 tan x, which is a required derivative of y dy upon dx. Here the value of y is e to the power x square into tan of x raised to the power x by 2 upon 1 plus x square raised to the power 3 by 2 into cos cube x, which is a required derivative of y dy upon dx. Next one, example number 3 is y is equals to x plus 1 raised to the power 3 by 2, 2x plus 3 raised to the power 5 by 2, 3x plus 4 whole raised to the power 3 by 2. Again the given function is in the complicated form. If we have to find the derivative of the given function, first we take log on both sides of the whole function. First we know about log of m n into w. If given three functions are in multiple form, then we can write it log m plus log n plus log of w omega. Secondly, we know about log of m raised to the power n, which is log m n log m. Here, if we apply log on both sides, taking log both sides, then we can write this y log y. Here, every function which is in multiple form, we can write it log m plus log n plus log w. Then we can write directly log of x plus 1 raised to the power 3 by 2 plus log of 2x plus 3 whole raised to the power 5 by 2 plus log of 3x plus 4 whole raised to the power 2 by 3. After applying log of m raised to the power n, we can write it 3 by 2 log of x plus 1 plus 5 by 2 log of 2x plus 3 plus 2 by 3 log of 3x plus 4. Now, if we differentiate this function with respect to x, then we can write the derivative of log y is 1 by y dy upon dx. Here 3 by 2 is a constant function. We can take a derivative only log of x plus 1. Here 5 by 2 again constant. We can take a derivative of log of 2x plus 3. Here 2 by 3 again constant function. We take a derivative log of 3x plus 4. We know that derivative of log x is 1 by x. We can write here 3 by 2 into 1 upon x plus 1 and again the derivative of x plus 1 plus 5 by 2 into derivative of log of 2x plus 3 1 upon 2x plus 3 and again the derivative of 2x plus 3 plus 2 by 3 is constant function. We can take a derivative of 1 upon 3x plus 4 into again the derivative of 3x plus 4. If we shift this y right side, then we can write only dy by dx is equals to y into 3 by 2. Derivative of x is 1. Derivative of 1 is 0. 0 plus 1 is 1. 1 into 1, 1. Hence we can write 3 by 2 into 1 upon x plus 1 plus, here derivative of 2x is 2. Derivative of 3 is 0. 2 into 1, 2. Hence we can write 5 by 2 into 2 upon 2x plus 3 plus 2 by 3 into, here derivative of 3x is 3, 4 is constant function 0, 3 plus 0 is 3, hence we can write 3 upon 3x plus 4. Here 2 cancel, here 3 cancel, we can write it, the value of y is x plus 1 raised to the power 3 by 2 into 2x plus 3 whole raised to the power 5 by 2 into 3x plus 4 raised to the power 3 by 2 into 3 by 2, 3 into 1, 3 upon 2 in bracket x plus 1 plus 5 into 1 is 5 upon 2x plus 3 plus 2 upon 3x plus 4, which is a required derivative of the given function dy upon dx with respect to x is dy by dx. The next question, which is question number 4, is y is equals to x raised to the power a plus x raised to the power x plus a to the power x. And here we have to find dy by dx. First we take differentiate with respect to x, then the derivative of y is dy by dx, which is a required derivative. Final answer. We take a separate derivative of whole function a to the x raised to the power a, x raised to the power x, a to the power x. We know that the derivative of x raised to the power a, which is the rules of x raised to the power n, is a into x raised to the power a minus 1. Here, the rules of derivative with respect to x, which is x raised to the power x form, is not given. Hence, we can write as it is derivative of x raised to the power x, and we know that the derivative of a to the power x is a to the power x log a, equation number 1. This is dy by dx. Now, we require derivative, the function which is x raised to the power x. Then first we consider that this whole function by u, let u is equals to x raised to the power x. If we have to find the derivative of this function, we take a log both sides, taking log both sides. Log of u is log u. We can write it log of x raised to the power x. Against this function we can write it x log x which is log u. Now if we differentiate with respect to x, then the derivative of log u is 1 by u du by dx. Here x and log x is two multiple functions, then we can write x into derivative of log x plus log x into derivative of x. If we shift this u right side, then we can write u into x into derivative of log x is 1 by x. Log x as it is, the derivative of x is 1. Here x cancel. We can write again the value of u 1 plus log x, which is the value of du upon dx. We know that u is x raised to the power x. Hence, we can write derivative of x raised to the power x, u means x raised to the power x, is equals to, again we put substitute the value of u is x raised to the power x in v into 1 plus log x. If we put this value in equation 1, then we get the required derivative, which is dy by dx, is a into x raised to the power a minus 1 plus derivative of x raised to the power x is x raised to the power x into 1 plus log x from equation 2, and the derivative of a to the power x, which is a to the power x into log a, which is the required derivative of the given function dy upon dx. Here the x raised to the power x 1 plus log x is from equation 2. Next one, example number 5. Y is equals to sin x raised to the power 10x minus x raised to the power log x. Again both functions, which is sin x raised to the power 10x and x raised to the power log x, is in the form of f of x raised to the power g of x. If we differentiate directly with respect to x, then we can't find the derivative of sin x raised to the power 10x and x raised to the power log x. Hence, we first consider that sin x raised to the power 10x is equals to u and x raised to the power log x is equals to v. Therefore, y is equals to u minus v. Now u and v again differentiable functions. If we differentiate with respect to x, then we can write dy by dx is equals to du by dx minus dv by dx, which is the required derivative dy by dx. Hence, we have to find two differentiable functions, two derivatives, du by dx and dv by dx. First, we take u. U is equals to sin x whole raised to the power 10x. Now, if we have to differentiate, then take log both sides. We can write it log of u is equals to log of sin x raised to the power 10x. Again, we know that we can write it tan x into log of sin x. Now, if we differentiate with respect to x, then we can write the derivative of u, log u is 1 upon u du upon dx. Here, derivative which is u into v form, tan x is one function, log of sin x is another function. We can write derivative of tan x into derivative of log of sin x plus log of sin x into derivative of tan x. If we shift this u right side, then we can write du upon dx is equals to u into tan x. Derivative of sin x is 1 upon sin x. into again derivative of sin x is cos x plus log of sin x as it is and the derivative of tan x is sec square x. Now the value of u is sin x raised to the power tan x. Hence we can write du upon dx is equals to sin x raised to the power tan x into cos x upon sin x is cot x and cot x into tan x is 1. Hence we can write tan x into cos x upon sin x means 1 upon tan x plus log of sin x as it is and the derivative which is sec square x as it is. Here tan x cancel, we can write it sin x raised to the power tan x plus sec square x into log of sin x which is the required derivative du upon dx number 2. Now we have to find the derivative of v and function v is x raised to the power log of v. Then second function v is equals to x raised to the power log x. If we take log both sides, then we can write log v is equals to log x into log of x. It means that it is, or we can write it log of x raised to the power log x is equals to log of x into log of x is equals to log of x whole bracket square. It means that log of v is equals to log of x whole bracket square. Now if we differentiate with respect to x, then we get the derivative of log v is 1 by v dv upon dx. Here if we apply the derivative which is x raised to the power n is n into x raised to the power n, then we can write the derivative of log of x whole bracket square is 2 log x. We can take again a derivative of log x. If we shift v to the right side, then we can write multiple of v is equals to v into 2 log x into derivative of log x is 1 by x. We know value of v is x raised to the power log x 2 into x raised to the power log x upon x, 2 into x raised to the power log x into log x upon x. Equation number 3, which is dv upon dx. Put 2 and 3 in 1, then we get required derivative dy by dx, which is du by dx from 2 is sin x raised to the power tan x plus sec square x log of sin x minus dv upon dx, which we can write from equation 3 2x raised to the power log x into log x upon x, which is a required derivative of y dy upon dx. Sorry, here 1 plus, it means that 1 plus. Hence we can write it 1 plus sec square x log of sin x minus 2 raised to the power log x into log x upon x, which is the required derivative of y dy by dx.